Gotta ramble about something. This is the Hackaday Podcast.
Hello and welcome to the Hackaday Podcast. I'm Elliot Williams.
And I'm Kristina Panos.
This is episode 277. We'll be talking edible robots, a personal Eclipse, and DIY PCBs to die for. This week in the news, we got Paul Allen's Living Computers Museum and Lab about to be auctioned. I guess Paul Allen passed away in 2018. He had amassed this incredible collection of first editions of all sorts of early and interesting landmark computers. They closed up during COVID, never reopened, and now his family is auctioning off the entire estate. So head on over to Christie's if you've got a few extra hundreds of thousands of dollars burning holes in your pockets, and you could pick up some really awesome old computers.
You know me.
It's like the high society version of the Hamfest junk table.
Oh, that's funny.
And then two pieces of Hackaday news. One, the business card contest ends on Tuesday the 2nd. So get to work. This is your last weekend. Go, go, go. We've had a ton of really cool looking entries into this one, but if we are still missing yours...
Yeah, I was going to say, we need yours.
Go. This is your weekend. I always say there's no minute like the last minute, and this is it, folks. This is the last minute, so go, go, go. And speaking of deadlines, it's not quite the last minute, but it's the next to last minute for call for participation for the Hackaday SuperCon. I'll throw links in the show notes. You've got until the week after Tuesday the 2nd. So not this Tuesday, but next Tuesday. You got your next 2 weekends scheduled for you. This weekend, panic on the business card contest. Next weekend, panic on your abstract for a talk at SuperCon. Seriously, we'd love to hear what you are doing. And of course, if your talk gets picked, you get in free. So head on over to the link in the show notes and you'll find the forms to fill out. Basically painless. You just need an abstract. You can do the work later. You got until November to get your slides done.
Plenty of time.
But you've got all summer. Go, go, go. And that's enough of that. Let's head on off to What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
This week is a Guess the Sound week, and I picked up not one, not two, but 3 instances of the same sound for you to listen to.
Really?
And I don't think I've uploaded it, so...
I was going to say, I don't think I see them.
Well, it's more suspenseful if I don't upload it.
That's true.
But they won't hear it unless I upload it. Hold on a second. There we go. How about that?
Nice. Oh, that's like a neon sign coming on or something, maybe.
Oh, that's a very good guess.
Oh.
I'll give you one clue that might get you in the right direction. Think retro computing / retro tech.
I mean, maybe, I don't know.
Oh, so super close. I think that's so close I might have to cut it out. Well, those of you listening in the audience, head on over to hackaday.com/podcast and give us your best guess, and I'll tell Kristina how close she got right now. No, it's a...
Oh, okay.
Yeah.
Neat.
Which is why it sounds both like a neon transformer firing up and... So, like, if you put those two together, you would actually have it, I think. Ooh, last time I played your Galaga sound that you sent in.
Oh, a ton of people got it.
And a ton of people got it. A ton. So I'm making up for it by being I'll be the bad cop to your good cop.
Some people were confidently incorrect, though.
Well, But period correct.
Yeah.
Everyone was in the right genre and the right era, even if they weren't. There's just something about chiptunes that sound chiptuney. So rolling on to the hacks, my first hack this week is the best DIY PCB method, and certainly that I've ever seen, is a long 2 3/4 hour video by 4 Hour Good. And you may have seen parts of this procedure before, but he's put them all together in one long take here, and kind of all of the little details are included in this video. And I won't lie to you, I skipped through it too and ran it 2 times, and even so, it's too long. But it's also chock full of really great tricks. And so, if you are doing any sort of DIY PCB stuff, it's probably worth having a look at least parts of it. And I tried to put a bunch of links in the article to some good timestamps for you. Basically, his procedure is to lean heavily on UV cure solder mask and then a kind of a CNC machining path. And for the CNC part, he's actually got just a really cheap CNC router. These things cost like $100. They're deadly cheap and actually a really fun way to get into CNC stuff. But, they're also dead crappy. But I digress. He's got a drill head and a laser head set up for this thing. And then he's got a PCB hot plate, he calls it, but it's actually a clothes iron upended. And he's got a UV exposer. And so what he does is he takes a bare copper board, cleans it super well, and puts UV solder mask on it and then cures it on there. So the whole board is essentially covered in a very thin layer of solder mask. And he actually does something neat here, which is he takes a piece of silk screen and puts it down over the top of it, the screen from silk screening, and uses a squeegee to get a very thin, very uniform layer of solder mask on there. Lets it settle for a few minutes and then boom, UVs it. So he's got a nice thin solder resist layer over the whole thing. He then uses the laser in the 3018 to cut the traces for it. Then he solder masks the whole thing again. Then he does a silkscreen step. Then he lasers out the copper again. And then he flips it over, puts the laser marks on the backside to show you where big components go. Then he uses an actually super clever alignment jig to kind of reorient things because he has to switch out from the laser head to the drill head here. And he centers the drill on this alignment jig, and then he has it drill out all the holes. Oh yeah, and for good measure, of course, he switches back to the laser jig and makes himself a stencil. It's the whole procedure. But what's amazing here is the quality of this board. Like, it's got 2 layers of solder mask on it, and he gets incredible resolution out of this. And a lot of this is due to his technique and having worked with these different UV curing resins a bunch. And, so I think some experimentation would be necessary for you to get similar results at home. But I just really love the idea of using solder mask as an etch resist here and then kind of lasering that away. And it's reminiscent of what people used to do in the old days with, like, I don't know, black Krylon or something. You'd spray paint black paint on the PCB and then laser that away. And then you could use the paint as an etch resist in a very similar fashion. But this seems to give him incredibly good resolution where, I don't know, I always had flaking problems and stuff with the black Krylon method. So this looks like it's even better than that. And these boards look so professional. It is outrageous. The resolution he gets on the laser-driven silk screen, the white silk layer, is just absolutely fantastic. You do not get that good quality from the PCB house. Of course, it doesn't take you 3 hours of labor either. And of course, the comments are like, "See, I don't make PCBs anymore. I only get them made," and blah, blah, blah. And of course, that's true. And for like 90-something% of the time, that's going to be true. But if you really need it right now, some of the steps he's using here are probably really good for you to see, because you could turn around boards with, he's using very close to professional space and trace levels on this. Like, if you're not doing the absolute smallest feature size, you can make it yourself exactly as you would have it manufactured, test it out, and then get a run out the door, faster than waiting 3 days to get it done and shipped in from China. Or maybe, like this guy, you just enjoy doing it yourself. That's cool too.
If you can get results like that, geez.
I would be totally happy to shortcut his method by just doing the UV coat, laser away, and then etch. I think that'll get you 4/5 of the way through his result with just one setup and minimal work. I think you can cut some good corners on this and turn it into a reasonable procedure.
Are you going to try it?
I think I will, actually. I've been wanting to play around with UV cure resins forever and ever. Yeah, it's a good excuse. I'll need to make some kind of funny UV curing box, though.
Oh, that'll be fun. For my first hack, I chose Dylan Turner's one-handed PSOHK keyboard doesn't need chording or modifier keys. I believe it's actually pronounced, wait for it, PSOC.
PSOC.
So usually when we talk about one-handed keyboards, with it, we're talking about some form of chording. And that's the act of pressing multiple keys at once to create a single character. Kind of like playing a piano. But this one-handed keyboard basically rearranges a standard keyboard to be one-hand friendly, with the maximum number of keys all within reach. In this case, 75 of them, all in wondrous Cherry MX Brown tactility. The keyboard was designed around a number of factors like the most common letters used, the relationship between sounds, which is very interesting to me, as in D and T.
Oh, I see.
The shape of the left hand itself, and then practicality, such as escape is in the left corner, well, familiarity too. Escape is in the left corner, all the function keys are there, the arrow cluster is like you'd expect it to be, and there's even a home delete cluster, like you'd see on a standard keyboard. Very cool. Provided your hand is big enough, I suppose.
That's a really sweet idea. Oh my God. So he's proposing to use this so that he can type with one hand and keep his other hand on the mouse at all times. This is a heavy mousing setup.
Or on a beer, you know.
Yeah, exactly. Type with your left hand. I like all the vowels are on the thumb. I wonder how that's going to work out long term. That's really a neat idea, though.
I like how much use the thumb gets here.
Yeah, we'll see how that works. That could either be a really cool idea or he's going to get carpal thumb syndrome.
Oh.
I don't know if that's a thing.
It might be because of this keyboard. Hopefully not.
Yeah, right? That's really cool. Yeah, for a while I had busted my left arm. My left hand was actually paralyzed, and I had to type with just my right hand on a regular keyboard, and I got surprisingly good at touch type swapping from side to side on just a regular keyboard. What's fun about that is I could still do it a little bit to this day. Like it's a learned skill that hasn't ever really gone away, and it actually is handy. If it was my left hand typing instead of my right hand, I'd be able to do, like him, I'd be able to mouse around or drink beer while typing, which would be much more handy. I might have to train that one too.
I think you'd be surprised at how easy it is. I don't know, compared to trying to learn how to mouse with your left hand.
Right. I think I just don't have the coordination in my left hand to do that.
I can't prove it, but I think I was forced to be right-handed.
Really? You think you're a native left-hander?
I think so. I remember my dad yelling at me when I used my left hand and for wearing my watch on my right wrist.
Mm-hmm.
It's like, no, you wear it on your left wrist.
Does that help? Do you think you have more left-hand dexterity because of it? Or despite it or whatever?
I have a decent amount. I consciously switched playing pool a long time ago to my left hand. And then I would break with my right because it's, stronger. And now I can't even break with my right anymore. It's like I can't shoot at all with the right. It's weird.
My next hack, $3 smartwatch can run Python, is a really cool hack by Poking Technology. It's a long video, but also he's got some GitHub repositories backing it up as well. He takes the dirt cheap M6 smart fitness watch, which is a kind of cheap Chinese clone of the Xiaomi Smartwatch 6, which is a good Chinese smartwatch. And these are one of those Bluetooth jobbies that connects to your phone and does stuff. The M6 has been, as he mentions in his teardown, completely value engineered to the point that there's nothing left of value in it anymore. What makes the Xiaomi watch plausible is that it has a big enough battery, but batteries are expensive. So this one has a crappy battery, etc., etc. It's like a horrible watch for what it is, but that doesn't stop him from reverse engineering it and playing around with it. Of course, standing on the shoulders of some other hackers here, I'll point you to R. Barron's blog entry from a few years ago, reverse engineering the M6 Smart Fitness Band, where he actually figures out the S-Wire protocol that you use to program this thing, Because when you open it up, of course, there's a little microcontroller in there and, a nice OLED screen and an accelerometer and a capacitive sense button. There's all sorts of fun stuff you might want to play with if only you could. And so our Baron's done a lot of this early heavy lifting in figuring out the absolutely bonkers and, as far as I can tell, unique S-Wire programming protocol. You can find the software development kit and compiler toolchain for this chip online somewhere, which is a really good idea, because this chip, the TC32, has its own instruction set. Like, you might think it was an ARM chip, but it's not, except it kind of is. And by that, I mean when Poking Technology is reverse engineering this thing. So he's got the SDK, he's compiling some programs, and then he's kind of reverse engineering it. Looking at the machine code instructions, the instruction set seems to do exactly what the ARM Thumb 2 instruction set does, but all the numbers are different. Like, all the opcodes are just scrambled. And it looks like they did this to avoid copyright or something. As he says, though, you could do worse than to copy the Thumb 2 instruction set. It's a really good microcontroller instruction set. So if you're going to rip something off, you might as well just rip that off. You've got the compiler, you've got the tool chain, you've got a way to program this thing. And so he tests that out in this video, gets a blinky LED demo. And then this is what happens when you let software people play around with hardware. Within an hour of getting this whole toolchain together, he's got a port of MicroPython up and running on this thing. And you can benefit from that too, because this one has been kind of dissected and spread out on a board and wires soldered to it and everything. And so he orders a brand new one of these $3 watches, tries to get that one running, in a more wrist-friendly form factor, and finds out that it has a screen of a different size. And so, there's a little bit more work left to be done on this, because different versions of exactly the same product will be different, because that's what you get with a $3 smartwatch. Regardless, in the end, this is a demo of a toolchain kind of put together by stealing the official SDK and then hackers reverse engineering the rest of it, and then some really hard work by Poking Technology to port MicroPython over to it, although he says it wasn't that hard, and that's a testament to how cool MicroPython is. So anyway, if you're looking for a dirt cheap Bluetooth-enabled microcontroller plus an OLED screen, $3. Phew, hard to beat that.
Well, you know what else is hard to beat? Building your own tape head out of a washer and some wire.
That is hard to beat.
Which brings us to my next hack. Build your own tape recorder player by Igor Brikhov. Okay, first of all, Igor makes a recording tape head out of just a washer with a slit cut out of it and a coil of enameled copper wire. And if that isn't cool enough for you, he goes on to make an entire tape deck in the second video. I don't admittedly understand all the way, but it's very, very cool. It receives a Bluetooth signal from an iPad, which gets amplified by the recording preamp that he built. He has it running through a homemade VU meter with op amps to monitor the levels with to show, output on LEDs so you can see if it's going to distort on your recording or not. It records, it erases, it does everything. Both of the videos are really interesting because of all the explanations of everything, so definitely watch them. And I'm sure you'll understand better than I did, dear listener.
If you want to understand what's going on inside a tape recorder, what do? You make your own.
Yeah.
Out of a split washer and some enamel. What?
Have you ever done anything like that?
Not at all. Closest I've ever gotten, oh man, back in the early 2000s, I took a tape recorder head and was, running it across the magnetic stripe on every card I could find with a magnetic stripe.
Yeah.
And that's kind of fun.
Yeah.
I remember being like, I'm going to find out the secrets in my credit card's magnetic stripe. And you do it, and it's like, Mr. Elliot D. Williams. It just said... I spent a day cracking this code, and it's exactly everything that was printed on the front of the same damn card that you could already read. But it was fun, and I got to play around with a tape playback head, I guess. But I didn't do any of the hard analog amplification audio stuff that he does here. I really just took it, put it in the probe of my oscilloscope, and ran it across a bunch of credit cards. That was the whole hack. It's not a hack. Do they even still make tape players? Is this what we're all going to have to do in the future?
Yeah, in fact, they have a ClearTech one at the half price books made by, the people who make them for prisons.
Ah,
And
okay.
it's see-through and I want one. It's only like $15
Right on. That's not
because I
bad.
love see-through things and I love tapes.
Yeah.
It doesn't have rewind though, or it says it only has 3 functions, so I assume it has fast forward and not rewind.
Do you think stop counts as a function?
Yes.
That's pretty cheap when you're counting stop functioning as a function. I hope you get play, fast forward, and rewind. I'm pulling for you. I have an old tape recorder that needs its bands replacing, and I even managed to find a replacement, an all replacement rubber kit for it.
Ooh.
And I was like, oh, I'm gonna do this, and I've never, because it's a like 1990s Sony. It's the Pro Walkman. It's a really awesome tape recorder, and it's 100 million tiny mechanical parts. It's like taking apart a watch, and I'm so terrified of it. So scared.
Yeah, I have the Sony Sports one, the yellow one that
Oh,
is like
awesome.
waterproof almost. Oh, I heard it so much.
Oh, I remember that one. Oh my God.
You get to open it up all special, and the lid opens really far. The batteries go on the inside.
That's such a great idea. A waterproof Walkman. Never mind that your headphones probably aren't waterproof.
Yeah. Oh well. Details. Oh, and that's such a small detail, but there's a little rubber door on it, of course, because it's water resistant. You can just change the speed of the motor right there on the outside of the player. If you
Okay.
need to. Yeah. The speed screw is on the outside. That's
Your
crazy.
tape is playing too fast. You can.
Yeah.
Well, this is one you should have picked. This time I picked the keyboard hack. Making Your Wireless Keyboard Truly Low Power by Pete Johansson. And he is the guy behind the ZMK wireless keyboard firmware. And this is a blog post of his where he goes through all of the kind of lower power tricks you might want to use if you're making a wireless keyboard. Because if you think about it, you don't want to have a really big battery in your wireless keyboard, and you want it to run for a long time. And most of the time, it's sitting there doing nothing. So you should be able to do this if only you throw a bunch of clever engineering tricks at it. All of these here are just kind of broadly applicable to any battery-powered microcontroller project you might have. And number one will surprise you, or at least it totally surprised me. I had never thought hard about this, and I'd certainly never measured it. His number one tip is if you have an addressable RGB LED on the board, you should use a MOSFET to turn its power rails on and off, because they have an idle current that's about 1 milliamp per LED. And so if you can imagine one of these like glowy, fancy, tricked out keyboards that has RGB backlighting on every key, what is that? You have 40 keys, 100 keys. That's 100 milliamps of quiescent current when the thing's doing nothing. That's going to kill it. And I couldn't believe this 1 milliamp figure. I thought that was outrageous. And so I went looking for verification, and I'll be damned. WS2812s idle at 1 milliamp each. And so I, for instance, went off to PJRC, Paul Stoffergen, the guy who makes the Teensy, and he's tested them out. 1 milliamp each for 2812s. Who knew? Anyway, the solution is to put them on a separate power rail so that when you turn them off, they actually go off. Even if it's just one LED, like 1 milliamp current, when it should be in deep sleep mode and most microcontrollers are drawing microamps at most, is an outrageous waste. That was the thing I learned out of this one. OLED screens can draw 15 milliamps when they're on, which isn't all that much for a display, but then they'll also pull about half a milliamp or so when they're blanked. So you probably should do the same power line switching trick with OLED screens like you do with addressable LEDs. He then starts worrying about the small stuff, and that's like pull-up resistors everywhere, leaking slowly to ground. And the one that I thought was interesting is he had a couple quadrature encoders that had 10K pull-ups on them. And so if you have those always running 10K to ground, that's actually pretty significant. I've seen, the I2C pull-ups. If you can get away with using the ones that are inside the microcontroller, you can shut those on and off. And so you don't have two 10K pull-ups on your I2C lines all the time. That's another great tip. Speaking of resistors, voltage dividers. If you're trying to figure out when your battery's dead and you're using a resistive voltage divider to knock it down to a range that your ADC can handle, his suggestion is to connect the low side of this voltage divider to a GPIO pin so you can turn it on and off so you don't always have this voltage divider string running all the time. Myself, I just throw a 1 mega ohm resistor in the top part of it. Use a big resistor and you get, let's say, 3.3 volts divided by 1 mega ohm is 3.3 microamps. So that's kind of small, but if you're down to that level where that counts, then, by all means, do his low side switching trick. I like that. Some voltage regulators have really bad quiet currents and some are really good. That's just something you should look at the specs for if you care about this. And then the last one and maybe the only one that's keyboard specific here, is that a lot of keyboards work by pulling the keyboard matrix all the time. So you have a bunch of row lines and a bunch of column lines, and you put voltage on the column lines and you see where they come off on the row lines. His suggestion is, instead of doing this all the time, which never lets your CPU go to sleep, you can trigger interrupts on the row lines and then do a polling sweep. So you can't get away from doing the matrix scanning, but you can put the chip into deep sleep until any key is pressed, and then you can do a matrix scan to see which key it is. And if you combine all these things together, I think he's right. You can get a wireless keyboard that will run for a long time, certainly in standby mode, for essentially ever if you throw like a LiPo in it. I think it's a really cool post and just a great treatment of low power issues in electronic designs of all kinds, but especially in the keyboard context.
All right. For my last hack, I chose Klein's 2024 Business Card Challenge. Noise card judges the sound around you. I don't know about you, but I feel like the world is getting noisier, even though the electric car is on the rise. Maybe it's just my neighborhood. We've got people with very loud vehicles, motorcycles, and then I've heard down in town people are ripping through town on four-wheelers and stuff. It's not good.
That's not appropriate.
No, it's not. But it's easy to judge whether a particular sound is painful, but let's face it, the decibels are doing damage long before the pain sets in. So this card seeks to inform the holder of the dangerous volume levels in various environments around them. It's solar powered, but it can go anywhere thanks to a couple of capacitors. It's based on a low power STM32, and there's a MEMS microphone on the back to pick up the sound, which the code is optimized for this particular microphone. Someone in the comments pointed out that because the microphone is not on the edge of the PCB, that it's going to give a directional, and I'm not sure why that's a bad thing. Is that a bad thing?
Yeah, that's probably fine by me.
So are we going for anyway, the LEDs on the front indicate the decibel range, and a handy silk screen shows you whether it's peaceful, safe, unhealthy, dangerous after 30 minutes, or dangerous after 4 minutes, which I didn't realize 105 decibels was dangerous after 4 minutes.
That's a pretty loud noise. I love that a bunch of the business card challenge entries went solar on this because, solar cells just about as thick as a battery, maybe even a little thinner. So it's like a perfect match for these. I think that's pretty sweet.
Yeah.
And this application is it's a great idea, and it's kind of out there. This is not one I've seen before, so kudos for originality here.
And good luck in the 2024 Business Card Challenge, which wraps up Tuesday, July 2nd.
Get it on in. Weekend, go! So my first quick hack, enjoy totality every day with this personal Eclipse generator, is just a beauty. Coming from Bernd Kraus in Munich somewhere. Hey, Bernd. Moon blocks out the sun. That's a solar eclipse. So he cuts out a giant cardboard moon and makes a 2-axis motor system to move it around so that it blocks out the sun from his favorite sitting position on his couch every evening so he can watch the sunset without being blinded. That's just such a lovely application, and it's made even sweeter because he actually gets a cutout of the moon and puts it on this cardboard disc and runs it for a long time. And then he's like, you know what would be even cooler? I only need to run this when the sun's shining. And so he puts solar cells on the back, switches out the ropes for copper braided wires, and now the whole thing is fully solar powered sun destroyer. Why did he do it? Just for fun.
Oh, that's so cool.
Next up, Soren Jurgensen. Llama TTF is AI in a font. And this is a crazy bit of software hacking. It relies on the fact that a common Linux library called harfbuzz, which is meant to let you put custom ligatures into various languages. So, if you have the double F, you can make a double F glyph and replace it with that. It runs WebAssembly underneath the hood, which means you can insert arbitrary programs into it. Here, Soren tosses in an AI, and the upshot of this is if you type a whole bunch of exclamation points, it then takes the space you'd have the exclamation points fill up and fills those characters instead of exclamation points with the output of a tiny AI model. It's absolutely hilarious. And then you change the font back to the other font and it's exclamation points again. And then you change it to Llama TTF and then it's your text again. Bonkers. Ryan Pickren, bats can no longer haunt Apple VR headset via web exploit, was a really neat proof of concept hack. Ryan submitted this bug that arbitrary websites could open up arbitrary things inside a viewer's Apple VR headset. And Apple didn't take him seriously, and so he made this proof of concept to convince them. And last up, coming from 3D Jake, which the commenters say is not the actual person in question, but a company name. And I went looking for this dude's name everywhere, and it doesn't seem to be Jake, but I can't figure out what it is. Had an awesome video called Adding Texture to 3D Prints. And this is one of those things that's so simple once you've seen it, you wonder why you haven't been doing it all along. He's taking interesting textures and in Blender bump mapping them / surface normal mapping them to 3D printed objects and then just printing them out. The end result is like a handbag that instead of looking like a bunch of 3D printed layer lines, looks like it's got a leathery texture because he put a leathery texture on it. When I say this is obvious, this is how you add textures to 3D models meant to continue existing in the graphical universe since forever. Like, this is the absolute standard way to do it. Why haven't we been doing this with 3D prints? Making fun, non-flat, crazy textured surfaces this whole time. I don't know, but now you do.
My first quick hack comes from EPFL in Switzerland. Tired with your robot? Why not eat it? Well, eating it is one way to get rid of the evidence of your failures, but that's not the point here. The team is combining food process engineering with printed and molecular electronics along with soft robotics to create totally edible robots for, let's say, medical purposes. That'd be a good one. They're making batteries out of riboflavin and quercetin. Quercetin? I guess.
If you say. I have no idea.
And others from activated charcoal electrodes on a gelatin substrate. As far as control goes, you can stack edible materials like oleogels, and you can make logic gates once you have all these things. Quercetin. Oh well. You say capo, I say capo. Next up, using the wind and magnets to make heat. This one is from Tim from the Way Out West blog. If you want to power your home directly from the wind, you need wind-powered induction heating. Tim's plan ultimately is to power his home with a windmill, but first he's got to figure out induction heating. So this is a prototype mechanical induction heater that uses alternating magnetic fields, much like an induction cooktop. Instead, Tim is using 40 large neodymium magnets of alternating polarity set around an MDF disc. He spins the disc via a drill press and some pulleys, and he's got himself a rapidly flipping magnetic field. He boiled water in about 90 seconds by driving the magnets at 1,000 RPM. And if you watch the video, he's got this other guy holding this copper pipe that's hammered down at both ends, and it's filled with water, and there's a hole in it so he can stick the thermometer in it, and this poor guy is holding it above the magnets all the way to 50 degrees Celsius, which that's a lot, right?
It's enough that I'd drop it.
Last up is Ivo de Haas's The Spinmeister for a perfect pizza every time. You're making pizza wrong. Don't you know that? Don't bother with a traditional oven because it doesn't get hot enough. What you need is a dedicated oven with a cooking stone, preferably one that spins slowly for even heating. So what Ivo did was upgrade their Uni Coda pizza oven with a stepper motor and a really nice control box that has a vacuum fluorescent display and everything. And the whole thing is portable.
So now it's time for our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to pick Al Williams' The Book That Could Have Killed Me because it was a little bit reminiscent for me, but then also for a lot of the people in the audience, judging by the comments. In this particular book, it was one of those like 1950s amateur scientists. This was C.L. Stong's version of The Amateur Scientist, which was before I was around. But it apparently, among other things, showed you how to make an X-ray machine. You know, it is a total do-it-yourself X-ray machine, from getting the glowing tube yourself to making the high voltage yourself and everything else. You know, as a nerdy kid, how could you possibly resist, right? So, you know, Al remembers having this book as a kid and totally wanting to make the homemade X-ray project, but having never done it. And kind of in retrospect, you know, when you're even a young teenager, do you really want to be messing around with hundreds and tens of thousands of volts? Probably not. You probably need to be at least this high to ride that ride, I think. Anyway, he reflects back on this one and some of the other even crazier projects that he saw in this book. You know, for instance, they had a 500,000 volt Van de Graaff generator. And the reason to do that, of course, was to make a linear particle accelerator and et cetera, et cetera. Anyway, it's a fun look at these kind of old school science books where everything was really, you know, here's how you can do this, even if the do this was kind of supremely dangerous. And I think that's what kind of sparked people's discussion in the comments about whether these days we're too worried about this or whether back then they were just a bunch of idiots. And what's fun is that with this linear accelerator project, actually, guy who wrote it up, Stong, called some people who worked in high voltage engineering whose responses were, "We are somewhat concerned over the hazards involved. The hazards of glass breakage, the use of mercury. We feel strongly, however, that there's an inadequate discussion of the potential hazards due to X-rays and electrons, blah, 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 blah. There will inevitably be generation of high energy X-rays. Currents with this, the resulting hazard is far from negligible. Substantial quantities of scattered electrons, some of which will inevitably pass through the observation people," et cetera, et cetera. Anyway, it's a very gently worded, holy crap, this is an absolute nightmare, which I think is also pretty pleasant. You know, what am I going to say? I had some of these books when I was a kid, and I think the worst I ever did out of any of them was some slightly sketchy things with mains electricity. But, you know, nothing like high voltage or X-rays or nuclear, which is where... or lasers these days, you know, which is where you get hurt without realizing you're getting hurt. And I think that's a lot worse in a way. The really high voltage stuff will get you dead before you know you're dying. And like, that's not cool because you can't back off. You know, whereas playing around with mains, at least in America where it's 110, you know when you're being shocked, and most of the time you can get clear. I did a bunch of dumb stuff as a kid and survived. You know, when you look at these books, there's a lot of dangerous stuff in there, and probably some teenagers did this dangerous stuff and survived, and maybe some of them didn't. And some commenters like, you know, I don't think this is a substantial contribution to teenage accidental deaths. And I think that's absolutely true. It's mostly like, you know, it's like yahoos playing around with fireworks or driving cars too fast or something. Like there's a whole bunch of horrible ways to end up dead as a teenager. And these are just the really cool ones. And I'm not. So I guess what am I saying here? I'm not saying go out and try to build your X-ray machine unless you do some serious reading on the safety precautions. And even then, the high voltage part, be extra double careful about. What's the stupidest thing you did as a kid and got away with?
I should think about that. I remember really, really, really wanting to build a go-kart when I was like 13 because I wanted to drive so badly. Just anything with a motor. A riding mower was like, yeah, I'll ride the riding mower. Sure. Well, I think I did once, and then it didn't work anymore. I don't know. It was an old mower. But yeah, I really wanted to drive. I never got, anywhere close to that. My brother could have helped me with that, though, probably. But he was already driving, so he wasn't going to do that. He had better things to do.
Yeah, my next door neighbor, Carl, got me into a bunch of dumb things. He was the one who showed me that you could actually burn wire by shorting a car battery, which is pretty cool. Melting thick metal wire is pretty awesome as a demo. we didn't get any of it on us, fortunately. Yeah, exactly. I blew up the first still I ever made because I sealed it. You can't seal it. The gas, it expands, it makes a steam. It doesn't all recondense. There's a lot of extra steam, and that makes things that are made of glass want to explode in your upstairs bathroom. Nothing actually like super dangerous like this. I think one of the commenters was like, people are so concerned about the risks of, X, Y, and Z, and he picks up mercury as an example. And I think that is partly true. Like, the risk of actually doing yourself serious neurological damage with a one-time exposure to mercury is very small. On the other hand, if you can completely avoid it, why wouldn't you? It's a small risk that you can entirely avoid, but it probably won't do you any long-term harm. My dad as a kid, his neighbor had a machine shop in his basement, small metal machine shop in his basement. And back then, when my dad was a kid, they used liquid mercury to cool stuff down. You could just pour mercury over something as you're turning it and cool it. And so he had, among other things, a shot glass of liquid mercury sitting around that my father drank on a bet.
What?
Which my dad says came out the other end fairly shortly afterwards.
Wow.
Because it's a very heavy metal.
Wow.
Yeah. Again, short one-time exposure. It's probably not what's going to make you insane. Or maybe it explains why I have this funny tic. So what the heck is the point here? A lot of these things are dangerous, and some of them are those kind of dangers. Like the one-time exposure to mercury is a very small danger that you can avoid if you don't do this experiment. And some of them are very big dangers, like getting zapped by a super high voltage power supply will kill you dead. And I think differentiating between these two risks is pretty useful. And I don't know how the heck they could publish these books back in the 50s. Part of me who knows better today than to try to make these projects think they're really awesome. But I'm not going to do it.
Well, should we talk about the Amstrad emailer?
Let's do.
For my can't miss, I chose Jenny List's The Amstrad Emailer, the right product with the wrong business model. It seems Jenny went to EMF camp and snagged this beast from the junk table. It's a 2002 Amstrad Emailer Plus. Basically, it's a landline phone that has a flip-up screen and a slide-out keyboard. This is basically the hardware parallel to the dotcom boom and subsequent bust, because this did not do very well. More on that later. Later models of this thing had a web browser, and even later, a camera for video calls. But the problem with the Emailer Plus was the business model. It sold at a loss and relied on a couple of different things, each worse than the last. A subscription-based ISP, a premium rate phone line, and a per email charge on top of that.
Ooh.
Yeah. That's pretty bad. That's a lot of bad.
And so nobody used it. Huh.
Yeah.
Go figure.
And so you could eventually get them at Tesco for £20. So now comes the hackability assessment. It still had the protective plastic on it, so it was probably unused. But unfortunately, Jenny couldn't get it to power up. When she got inside, she found a Sharp ARM processor and a Connexent phone line and modem chipset. There are serial and USB sockets around back, and an unpopulated parallel port. So now Jenny has to decide what to do with it. Does she upgrade it with a Pi and a new screen? Or does she put it on the next junk table? Perhaps at SuperCon. Does SuperCon needs a junk table?
SuperCon needs a junk table like it needs a hole in the head. What are we going to do if we have extra junk at the end of the show? Who's going to take it all? Not it.
So I agree wholeheartedly with Jenny. This is a very cool product that should have gone farther. And it might have done just that with a different business model. Because I could see my mother using that today, for instance. I wish it had a bigger keyboard, because that keyboard looks very painful to use.
So I'm just trying to put myself back in the 2000 mindset, right? Where everybody's still got a landline phone at home, but some people don't have computers to send email on. And, email is kind of the new best thing. And so this is where that device fits in. I think that is actually pretty good. And I was thinking to myself for half a sec about, what a weird bunch of functions to put together, a phone and an emailing device. And I'm like, oh, that's my damn smartphone. But what a cool idea, it kind of makes the corded phone this like information technology hub.
Yeah, makes me think web TV.
Yeah, exactly. I was trying to remember the name of that. Thank you.
You're welcome.
Web TV. Yeah, it's funny how there are all these kind of intermediate technology steps that look very intermediate from now that may not have at the time, right? Like,
yeah.
So Jenny did this teardown. She says the thing doesn't boot up, and I'm like, oh, I'll just look at the board and find the 2000s era bad capacitor that she needs to replace, right? Because that's got to be the story. And I look at it, and it looks like there's 2 resistors and a ceramic capacitor in the upper left-hand corner that are just like monkey soldered on there.
Oh, yeah.
Everything else is surface mount, and those guys, there's like a diode,
Yeah.
a ceramic cap, and then a couple resistors. What is going on up there? It must be like a power noise filter or something, but that's an ugly bodge. Yeah, you see it?
Yeah.
Well, that wraps it up for this week's Hackaday Podcast. Thanks a ton for listening. To follow the links or leave comments, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us a link, tips@hackaday.com. And until next week,
Keep on hacking.
yeah. And coming up, and
Yeah, I'm using this ice pack like a wrist rest. It's pretty nice.
why did I not put this guy's name in here? Because I don't know his name is the answer, but oh my god, help me. Beep, cut. Moving on, not recording any of this.
Stay away from metal.
Stay away from metal?
Do you have Swedish O on your keyboard?
Fooled myself.
Won't get fooled again. Yeah!